it all seems kind of ethereal, and I have to tell y'all that tech is hard to touch and the impact is hard to touch. It all seems like the stuff is coming, but none of it's quite here yet. And then I had the great fortune to meet Bert, Haskell, Chief Technology Officer from Con Street, and took a tour of a lab just right here in Austin in Mueller, 3 miles down the road that way. And I was absolutely blown away that it's really smart city technology in action. It has been for a number of years, since 2010. Thank you. So I thought, what a cool opportunity to not just talk about the future and what's coming and how important smart city technology and IoT is to real world problems right here in our communities, but what's actually already been happening. So I pulled a line from the website that I think is kind of fantastic. You know, smart cities there's such an opportunity to solve very real challenges in our cities. And this is from the Con Street website. I say, we're not trying to solve all the world's challenges, just the 2 biggest ones, water and energy. I thought that was really wise. So before we get into the Con Street, Bert, just tell us a little bit about your professional background and what you've been up to, and then next what's happening at the Con Street, and just a little overview about what you guys are doing.
Sure. So I joined the Con Street 5 years ago, or 6 years ago now, 2010, and prior to that, I had been working on thin film solar panels at a company here in Austin called Collier. And I worked there for about 4 years as director of product development. And then prior to 2007, I worked in the portable electronics industry. Spent quite a few years in the 90s at a company called MCC here in town, if any of you remember that. I ran the portable electronics business over there. We did a lot of research and product future research in the portable realm. And then between 2000 and 2007, I've done a bunch of startups, wireless technology, flat panel display technology, notebook computing. I was over at Motion Computers for a while. And then I did mobile chipset marketing at AMD, and probably a few other jobs I have forgotten since then. But for the past 6 years, I've been very much on what we're doing now, which is kind of an interesting hybrid between my former career in portable electronics and systems design and systems engineering, which we do a great deal of at the Con Street, but then also this whole renewable energy and sustainable water field as well, which is a far cry from the early days of consumer electronics. So it's a totally different application for some of the very same technologies that brought us smartphones. So that's kind of my background. And then as far as the Con Street goes, we're actually set up as a nonprofit. We got a $10 million grant in 2010 thanks to our CTO, Bruce McCracken. He wrote a grant. He was the only employee. And we won that. Basically, it was a energy efficiency stimulus grant from that, and he won it for Austin. And so we set about monitoring people's energy usage and also subsidizing their acquisition of rooftop solar and electric vehicles. And by doing those 2 things, and also by not being run by a utility, but actually being run as an independent company, we were able to achieve some things that none of those other grants were able to achieve in terms of actually installing things behind the meter and getting customer data. So that's where we cut our teeth, was on going into people's circuit panels, putting in CT clamps, streaming all that data out of the house over their internet connection instead of through a smart meter system, which didn't work. We tried that as well, but those systems were not engineered to do that. So we sort of cobbled together something that produced a huge amount of really useful data. And so today that data is available. We make that available through a portal called Dataport, and we have both academic researchers using that free of charge, and then we also have commercial customers which pay for that to use that data. So that's one income stream. So since our initial grant ran out in 2015, we've actually become much more self-sustainable. We have about a third of our revenue is commercial customers, companies like Intel, LG Electronics, 3M, Dell, and those types of companies. And then about a third of our funding comes from foundations, and like the Environmental Defense Fund or Verizon Foundation and some others that are interested in, basically bettering humanity's plight here on Earth. And then the last one would be we also get money from the state and federal government. So we have a big water grant from the state of Texas to help municipal water utilities basically help them figure out how to modernize their infrastructure. They're having a big problem now doing that. Smart meters are not common on the water side. They're more common on the electric side. The water utilities don't have the budgets or the expertise to really upgrade that intelligently. You may have read in the paper, Austin is getting ready to spend $80 million sometime in the near future, maybe in the next couple of years, to upgrade their water system. And we work with engineers from Austin Water, but there's still a lot to be learned before you go off and spend that much money. So I think there's a lot of, from a smart cities perspective, we're starting to engage in that a lot more. Our initial research was really focused on helping utilities deal with disruption, but more and more it's also about helping the cities with other similar types of problems related to centralized infrastructure and what happens when that becomes more dispersed and more distributed.
Yeah, there's so much to dive into there. There's a big push in Austin right now for nonprofits to have an earned revenue stream where they're not just dependent on foundations, not just dependent on public sector dollars, and once again, you guys are really ahead of the curve. And at the same time, smart cities, we were just talking with Beverly Ryder from Ericsson last night, and she's leading voice in IoT and smart cities. And one of the things that she kept talking about was just how difficult it is for cities and municipalities who have always looked at technology companies as vendors, and now it's a changed paradigm. It can't be the city over here just doing contracts with companies. It really needs to be a collaborative effort, and I think you guys are very early in that world, really testing it and showing positive results of what happens when you get university and private sector partners and public sector partners in kind of a safe collaborative space where it is truly a lab and you can experiment and ask questions and form hypotheses and say, nope, that's not it, let's go down this road, nope, that's not it, let's go down this road, and have the opportunity to kind of experiment out there.
Sure. Yeah.
So you brought some pictures about some cool stuff that you guys have been doing. It's not just theory, it's work in action. Go through and
Sure.
take us on a virtual tour of the lab.
Okay, I'll do that, yes.
Cool.
So, can you see the display?
Ryan, away, can everybody see this?
Okay, so this is our, we built part of the funding we got, we used it to build a lab, so the DOE actually still owns this building. Like, we were able to use it as long as we continue doing this type of research. This is a 3-story building over in the Miller community, right across from the airport tower. This is the first floor. The first floor is just an open floor plan and kitchen, basically. And so most of us just work around this table. There's 10 people in the building. We have a finance and HR director that offices outside the lab just because we're tight on space. But
Work 80K watch soccer.
yes,
I mean, you have to have
that's
fun
right.
while you work, or
That's
else
right.
it's boring, right?
Right. So so we're watching the Olympics there, but that was this afternoon in the lab, and so we've got our electrical engineer, one of our project managers, and we're just sitting around. We've got people working in the garage. We've set up, and I'll show you pictures of that. We're doing some work with the Department of Energy on something we call the energy switch. So I'll show you that in a moment. So that's the kitchen from the other point of view. So this is our garage. Right now it's full of stuff. We have actually 4 energy switch units, and you can see this is one of them here. It's about the looks like that's right, yes. It's about the size of a refrigerator. And what this does is it has 9.6 kilowatt hours of energy in it, so it's about 3 times as much as a Powerwall in terms of energy storage. Tesla Powerwall, if you're familiar with that. And then you can plug solar panels directly into it. you can plug a natural gas or diesel backup generator into this device. Obviously, you plug your grid connection in here, and there's a transfer switch built in. And then you reroute, in our version of this, we reroute the residential circuit panel through the device, so we have 100% load monitoring and control through this system. And so we've built, we're in a contract right now with the DOE. We've built 3 of these. We're getting ready to deploy 2 of them in the Miller neighborhood right down the street from this location. One of them is going to NREL, where it's going to be tested and verified, and then we're going to keep one in our lab for future development work. This is we call it the energy switch. That's the kind of just the working name for it. We've also got a commercial. We're working on a commercial version of that with some different name.
So it's an energy monitor?
It's actually an energy control system, so it stores energy and it switches energy flow. So there's a number of modes. There's 5 modes of operation, primary modes, and there's a lot of sub-modes. 2 of them are on-grid modes, 2 of them are off-grid modes, and one's a bypass mode for maintenance. The 2 on-grid modes include one mode where you've got unidirectional energy flow, so you only can pull energy off the grid. You can use that energy to run the loads in your house or to charge your batteries. You can also use your solar panels in that scenario and charge your solar panels with your batteries with your solar panels. But you can't push any energy back onto the grid. And that's an important mode that a lot of solar and battery systems don't have. But as utilities become saturated with solar energy, they can only allow, some utilities can only allow customers to have solar if they have that capacity to block energy from flowing back onto the grid. So we have mode 1. And then the second mode is bidirectional energy flow. And that's for full transactive energy. So you can buy and sell energy to and from the grid whenever you want. You can charge batteries, you can discharge batteries, you can push your solar out there. You can do pretty much what most people would expect, but cannot do when they buy a solar system today. And
So can I ask a question?
Yes.
So right now in my solar system, if the grid goes down, I'm out of power.
Right.
So, but what you're saying is that this thing would store and I would be able to use it like a generator?
Backup generation. And that's one of the key value propositions for the product. There's about 1.5 million natural gas generators now in the U.S., which are residentially owned, and they cost about $8,000 installed, and there's no payback for that in a traditional sense. The utility would say there's no way people will buy that because their electricity would cost too much, but people are buying that because they want to have 100% reliable power. They want resiliency. So
So
that.
if you wanna be off the grid, zombie apocalypse kind of stuff.
That's right. Yeah, exactly. So that's what's driving a lot of the economics behind batteries. And you'll hear some people say battery technology is not cost effective enough, or that it's going to be expensive for a long time. And it's just not true. It actually pencils out in places like Hawaii, where the cost of energy is so high that you can actually store energy and use it cheaper than you can get it directly from the utility. And then in other places where power is not reliable, it's with a generation system. And of course, if you have solar and batteries, you're getting your backup power without burning fuel, and that's significant savings. Okay, but this is an this is a thing on the internet. So it's kind of a big thing.
You saw it here.
But there's a little front panel, or a little display on the front panel, so it's for resiliency purposes, this device has to be something you can walk up to and control without any outside, can't be remote. If your internet goes down and the grid goes down, you have to be able to control this directly. But we also have an internet connection, so you could control it from your phone. Third-party aggregators could control it. You could have a deal with the utility where they're able to execute certain functions if they want to use it to augment grid services. So
as a consumer, you can really be not just a consumer on the grid, but a participant.
that's right. Yeah, you'd have the ability to enter into a lot of sophisticated control and transaction scenarios. You can use blockchain types of transactions to buy and sell your energy. So what we're building, we don't have the solution for all those higher level services. What we have is a platform that makes them possible. You know, we can do voltage control, we have power factor correction in both directions. So we've got something that is capable of doing all the things that people are talking about doing with a fully distributed energy network. This is just another picture. Down there at the bottom, there's you can see 3 shelves and there's boxes in there. Each one of those is a 3.2 kilowatt hour LG battery module. And they cost less than $400 kilowatt hour, which is, I don't know, 50% reduction over what they cost like 2 years ago. So the prices are just dropping. There's lithium ion, yes. Yeah, lithium ion, iron phosphate chemistry, something like that. And then this is our second floor lab, and up here we have a lot of measuring devices, mostly CT systems. We've also got a lot of modems and radios. So this is where we put sensors together with Raspberry Pis or similar platforms, Arduino kits, and we build sensor packages and gateways to pull data out of houses. And so we do this now as a product development service for a lot of really big companies. And we're able to, you know, combine not only electrical measurement, but water measurement, natural gas usage measurement, in, you know, temperature at different points in the house. We can talk to the smart thermostats and collect whatever data they're getting. We can stream in weather data. That's usually kind of important if you're looking at the energy balance in a home. Motion detection is often of interest. We're just as a company, we're kind of staying away from the home automation stuff outside of energy, water, and gas usage, just because so many others are there. But in the space that we're
We
in,
can only solve 2 of the world's largest
That's
problems
right.
at a time.
That's right.
Nobody's asking them that much.
yes, that's our thought. So anyway, that's what the second floor lab looks like. This is around the corner a little bit, and what we have here, basically in the very back corner, there's a rack of equipment. That's all of our, yes, that equipment rack back there. That's about 8 terabytes of residential energy data that we stream directly from our devices. We don't use third parties and their equipment and their cloud monthly fees and cloud services to get our data. We collect data and we stream it directly to our own servers.
And you
then
own it.
we own it.
Yeah.
And then we also back it up on the cloud. But we learned very early, it's really important when you're in this type of business to have direct control of your data collection resources and the data itself. Next to that is a 3D printer, which we use to print housings for our different sensors and gateway packages. And then over this corner, we do a lot of assembly and system testing. And I'll show you a close-up picture, but we've got a few things back there. One is we call that Blue Enterprise. We have a gateway called Blue Cube, which we put in homes to read a lot of devices, and it can also talk to utility meters outside the house. But we use this Blue Enterprise if we want to create a backhaul independent of individual residences, and then that can be placed on a pole top or a tower or even one of the houses, and can talk to a lot of systems within a neighborhood. And then
Based on,
what's that?
what's that based on, like a Raspberry Pi?
Yeah, actually it is a Raspberry Pi, and then all different kinds of radios that we put on there. You know, from time to time we get companies like Intel or Freescale. They have their versions of those platforms, and sometimes we'll do a project of those, but typically we use open source stuff just because it's easier and faster. That's close up in the printer. We're printing a Blue Cube housing in there right now. And then this is a circuit board printing system, a polymer printing system, so we can actually prototype. You wouldn't want to use this for any kind of deployed product because the materials here are not stable. I've been working on polymer circuitry since the 90s, and they still don't work quite right. But this is a really good way to quickly check out a circuit and make sure it works before you send it out and have boards fab. So we use that from time to time. this is a laser cutter that we use for precision 2D parts. And we also, I don't have a picture of it, but we also have a surface mount, a manual surface mount station, so we can populate our own circuit boards, prototype that way. So one of the things, and then this is a gateway. You can see the Raspberry Pi in there. This one has a little Wi-Fi module, and then we've got, I believe this is a 900 megahertz antenna that talks to certain types of Itron gas, water, and electric meters.
Is that a 3D printed box?
Yes, that's right. Now, we did just start, with this product, we had a mold made in China, and we're going to be printing this because we're starting to get a lot of orders. We've got to make about 1,000 of these now for a couple of different water utilities in Texas. And so this particular one is 3D printed, but we have just gotten samples of our fully molded version. What this does, this has a Hall effect sensor inside the box, and that ring, it's snap fit to that, fits a particular type of legacy utility water meter. It could be a 50-year-old Badger meter. Austin has a lot of really old water meters that are still in service. And so what you can do with this is you can just print a ring that fits the particular model of meter. You can snap it on top of the existing mechanical register, and the Hall effect can pick up the sweep of the magnetic coupler, which is used to drive the magnetic display that the meter reader is able to read. But we're able to count the reads in here and then transmit that through different types of radios back to our database, and we can get extremely granular resolution of water usage.
So does someone have to read the meter and enter it into your database, like as a starting point?
No, so interestingly, this eliminates the need to read the meter manual. I mean, it's streaming data back every minute if we want, or even more frequently. Typically what we'll do is accumulate, unless we have some kind of real-time application, which we do have some for irrigation and so forth, we'll just accumulate the data and then send it back in bulk. And we can send it back over cellular or over the homeowner's Wi-Fi. It just depends on the situation. Or we can deploy some special collectors. But yeah, this eliminates the need. However, in most utility deployments, because of the way utilities work, you can only do experiments like this if you don't affect anything. So what we did is we had to come up with something that would turn their meter into a smart meter, but still allow them to go through their normal procedure of reading all the meters until such time as they replace them and stop reading them. You don't want to interfere with their normal process.
So you're disrupting the system, but not disrupting the system
Yeah.
at exactly the same time.
That's right, yeah, we work around the utilities procedures constantly. We did a lot of that. We learned how to do that in our electrical work as well. Doing things that don't require anybody at the utility to change anything they're doing, then they'll help.
And I think it's an important part of the experimentation, whether it's a city or a municipally owned utility or a separate utility, being able to have those big bureaucratic organizations not be interrupted while you're innovating at exactly the same time.
Right.
And I'm just so fascinated and grateful that you all are working out this model. I think it's important here in Austin, and then hopefully you can work with cities all over the country and all over the world, having that safe place where you can do things like this and experiment, and it's not on the city staff or contractors to really figure this out because the stakes are too high to really experiment.
Right, absolutely. Yeah.
Is that per residence or per community or?
That's per resident, so that fits on a single water meter.
Okay.
Yeah. And then we've got, I don't have a picture, but we also have a product that goes with this called Blue Garden, which is a sprinkler automation controller that we've developed. It plugs into any sprinkler system. It would replace the controller you have, and then there's a mobile app that goes with that. And the big difference in that product is that it waters based on actual volume of water that's flowing as opposed to time. Most water systems you set for 15 minutes or 10 minutes per zone or whatever. And water pressure in Austin anyway can fluctuate 30 or 40%. And so that means your water, the amount that you're watering is actually fluctuating 30 to 40%. Most people don't realize how much water irrigation uses. A shower, for example, uses 8 gallons, or a toilet flush might use 3 to 5 gallons. A watering event, an irrigation event in a Central Texas home uses about 1,500 gallons. And so, you know, you use more in one watering event, you use more there than you really use all month in your house. And that's really the only thing that matters when you talk about water conservation in Central Texas.
You know, when you said about not disturbing the existing water utilities really don't have a motivation for conservation. They're kind of between a rock and a hard place, and, you know, they want to be seen as good citizens in the community, but at the same time, they don't really want to push conservation too much because that's where they get their money.
Yeah, you know, revenue, and same with the electric, what we see happening on the electric side, and this hasn't happened yet, but what will ultimately happen is they'll move to some type fee for service or more of a quality of service-based billing as opposed to quantity of resource billing. So it's like, you know, billing people for bandwidth versus kind of a flat fee for having a certain bandwidth available, but not a certain amount of data. So it's you're absolutely right, and that's just a legacy. That problem is it doesn't have to be that way. You don't have to bill people for the quantity they use, but the utilities have to struggle with it. It's very whenever you transition that, there's some winners and losers, and so it becomes a big political issue.
Do you think that'll transition relatively quickly? I mean, it seems like every large-scale entity, whether they're corporations or cities or utilities, they're all having to adjust to the coming age, which is not very far. I mean, 5G is less than 4 years away, according to earlier. Our Ericsson last night, so that's my source for that stat. But I don't know, what do you see in terms of transitions and how quickly and are people ready?
Yeah, water is kind of different because every part of the country has a different situation. So, I mean, where there's crisis, I mean, if you go to Phoenix, we don't even understand what they're saying when they tell us about what they're doing with water conservation. I mean, they're very far ahead of us, but they, you know, they're not. They don't have a strong motivation to go out and tell everybody what they're doing. They just fix the problem, and it's basically, you know, there's no real irrigation that goes on there, and if it does, it's very very controlled. So, in Texas, I think that if we had a crisis where there just wasn't enough water to maintain health and so forth, you would ban irrigation, and you would have plenty of water.
It's hard to imagine over the past couple of days, it's been raining nonstop. I was driving around just a couple blocks from here, and there were sprinklers going on and a torrential downpour at the same time. So, you know, it doesn't hurt till it hurts, but hopefully we can be a bit wiser about it in the shorter term.
Yeah, and I think the real tipping point on water is when we have some like a solar energy equivalent for water. In other words, when you're able to like recycle all the water you need on a residence, then you've got real resiliency. And you know, we've seen like the Flint, Michigan, but that could happen anywhere. Any public water supply can become contaminated, and then you have a real problem. You know, 2 million people without water in Central Texas would be a big problem. So to the extent that people have some kind of backup recycling system in their home that can produce enough water to sustain them, that's something people would probably pay for if we can nurture that technology make it available.
Is that something you would consider testing and commercializing
I'm
demonstrating?
very interested in that. There's a few things out there right now that are working in that direction. And I think we're going to be getting into testing some of that pretty soon.
So that talks to your gateway or?
Yeah, that'll talk to our gateway.
Is it a low power wireless interface or is it?
Yeah, so you're right. So with electric meters, you've got a power source. With water meters, you have to do everything with a battery. And you need a pretty long lifetime, like 10 years. And so we're able to stream very high resolution data out of that with very low power consumption. And we've got about a 10-year battery life. So the power management that we're using in there is very sophisticated. We had to create something, you know, just to make that happen.
I know Europe and France, the whole country has gone to they're low power, it's not 802.11 wireless. It's all different kinds of wireless and competing, formats. So, they seem to be, I know Cisco got a big contract to implement water metering in France. So they seem to be further along, they seem to have agreed upon a format.
Right.
As opposed to here where it seems to be a free-for-all.
I mean, it's I witnessed the whole European GSM and Europe implemented GSM and everybody said, wow, they're kicking our butts and all that stuff, and then it turned out to be not as good as what we implemented. And so, they got off to an earlier start, but then when it took off here, we just flew right by everybody else in terms of cellular standards. So, but you never know, and it almost doesn't matter. What we're focused on is, this little grommet right here. We put more engineering into that than the radio, because that grommet is a cable that goes to whatever radio we want to stick on it. Okay, and we can put a cellular radio, we can put Wi-Fi, we can put any kind of endpoint, on that. But the engineering was to make sure no water gets in the box when that thing is underwater and you've got your radio connected to a cable up on the top of the meter.
Oh, okay. So you actually have to put an antenna up there on the, okay.
Yeah, because they're underground and they could be
Yes,
underwater,
yes.
and then sometimes the meter covers are metal.
Yes,
So
they
you've
are.
got to either pop through that, or if it's a plastic one, you've got to mount it right to the top of the
All sorts of constraints.
yeah. Yeah, that's actually a picture of it. Now the body is black, the ring is blue, but the meter, you can see it snapped on the meter body, and then there's the radio cable coming out. And then that radio cable can plug into any number of endpoints. This is one that we actually bought from a meter manufacturer. I believe this is an ERT radio, or it might be a cellular. But anyway, it's got its own battery system and a 10-year battery. But we're starting to make our own endpoints as well that are multi-band, multi-protocol radios.
So 10-year battery, what does that mean?
Well, it means under.
Does it depend on the protocol that you use, or?
Yeah, I mean that all varies immensely by how you decide to make the connection.
You're talking about a 10-year charge or a 10-year lasting?
10-year charge. That's what they. But there's a lot of meters out there, particularly water meters. So those utilities that have implemented AMI in their water systems have found their meters are dying in like a year. And it's a big problem for the industry actually. The meter manufacturers promised 10 years. They didn't understand how the radios. They didn't test them thoroughly. They didn't understand that the radio would be dialing in multiple times just to send one packet of data because it couldn't connect, and all of a sudden these meters are in the ground and they're useless, and you know what, you can't swap the batteries out of them, you gotta replace the whole meter.
No.
Yeah, so there's a lot of lawsuits that happen.
Oh, my God.
Yeah, I guess that's it, that's kind of a quick overview of some of the things we're working on.
I think it might be interesting if in your design you included something that looked at the battery and kind of predictive fashion, look at, okay, are you using up your battery a lot faster than expected with the data that you're pumping out?
Right.
Are you getting, when you access information from the devices, is that information available? I guess I'm not sure, I guess you're just monitoring water volume, but for the device inside, for its maintenance and its health, do you pull any data? Like SNMP data?
Yeah, we do that. It just depends on where we're at in product development, but yeah, we can diagnose the systems, we can in some cases we can put new firmware in there, we have all kinds of different systems out there. One of the, not deploying a fully baked commercial system, we have the luxury of doing research, and so we have to make things that are robust, and in some cases they're more robust than commercial products because we care. But when you're doing research, you just get to operate under different parameters. Cost is one of them. I mean, we rarely charge people for any of this stuff. We mostly mostly given away. We get funded to collect data, not to build devices. So we can spend, these are probably going to be about $200 or $300 a piece. They're still cheaper than smart meters, but they're not dirt cheap to install.
And so there's a commercialization aspect to what you all do, or are you just kind of experimenting with that?
No,
piece
we
of
have
it?
a ton of that. Yeah, we can license a lot of this. We can, we've got a number of things in progress now when we're starting to commercialize. The energy switch I showed you at the beginning, that's one where we're, either going to license or we haven't decided the path to commercialization. We've got home builders that are interested. We've also got battery manufacturers that are interested. So we've just got to kind of figure out the best place to take that and how far we want to take it before we license it or sell it to someone else.
It seems like you all have kind of created either the holy grail or the Pandora's box for smart cities.
Yeah.
I guess time will tell, right?
Right.
And from the outside looking in, where there's so many cities facing these challenges, and you guys are just, I think, really onto something in terms of the model. I mean, what's next? Do you replicate labs all across the U.S.? Do cities come to Austin, Texas, to learn how to do this and potentially license the technology?
Right.
How can we take what you have done and make it in service of cities all across the U.S.?
That's a great question, and we spend a huge amount of time hosting visitors from other countries. We're probably more well known outside of Texas and the U.S. than we are here.
Interesting.
Yeah, for sure.
Why is that the case?
Maybe like you said, France is doing something. These other countries, this is not a good generalization because the U.S. has so many different regions, but in general, there are some other countries that take this a lot more seriously, this kind of stuff. And so, and there's also a higher tendency for the government to get involved. And so what happens is we get a lot of government-funded delegations that are coming through to learn best practices. And so we show them what we're doing. We have tried to commercialize that. It's like there's a revenue stream around just telling people how we do what we do because we do things very fast. And that's the function of reducing our cycle time. We can make things quickly, we can install them. And so there is an opportunity to do that, but it ends up getting done kind of in our spare time. That's how it mostly happens. But it does open, that visibility opens us up to, the opportunity to get into maybe some international projects. And we've done a few of those. We did some stuff in Amsterdam. We might, we're looking at some stuff in Korea and India as well.
Those smart city projects are really inspiring, and at least in Amsterdam and some of the European countries, to your point about why isn't this happening all across the U.S., the geographic space is just so different. And when you were talking about building out cellular and mobile broadband networks, building across the size of the United States just requires a completely different allocation of time and resources than it does in a small geographic area. So maybe that's part of it, and smaller, more nimble government.
So, are there, in all this, right, small governments, they can sort of they can mandate the two things they want to solve and they go ahead and do it, right? And you guys have a lot of good technology, and it seems like you're working on a lot of different use cases and trying to educate as many different constituencies as possible. Maybe this is a question for you. Are there 2-3 relatively low-hanging fruit type use cases that can start to roll this out on more than just like a city-by-city basis? Is there a baseline use case that you're starting to see municipalities, local governments across the U.S. start to really latch onto?
Yeah, it depends on what aspect of what we're doing you're kind of referring to. In terms of the IoT stuff, what we've observed is that it's really maker technologies that are driving IoT. IoT is not new in concept, and same with data analytics. So, what we're doing is we're developing deep domain expertise. So IoT and data analytics skill sets are kind of useless without domain expertise. And so that's what we're really focusing on is, we're we're driving in community, we're developing domain expertise on things that are of importance to our local community. And, we'd like to see other people doing that.
Because that's a problem with analytics in general, is you can collect all the data you want.
Right.
In telecom, that's still a huge problem. There's sensors everywhere, but they still haven't figured out how to actually monetize it
Right.
effectively.
Yeah, and we've been looking at energy data for 5 years, and lots of it, and we're still coming up with better ways to visualize it. And it's really, the visualization research is important because when you stumble on the right visualization, everything else gets easier. When it comes to like artificial intelligence is really hard, but if you've got a visualization method that if a human can't figure it out, forget making a machine do it. If a human can figure it out, maybe a machine can do it. So the easier it is for the human to visualize what's happening, the easier it is then to help the machine figure out what's going on. So visualization is really critical. And it's something we do, we spend almost the smallest amount of our resources because we're collecting the data, and the data is unique and nobody has it. What we want is more people to look at our data and buy our data from us.
Leave it to the intelligent world.
Yeah, but get that data and look at it and figure out how to really turn it into something, because we have enough people to do what we're doing. We don't have enough people to interpret all the data we're collecting.
When I read something interesting that Brewster wrote around making sure you're collecting the right data, and it's a waste of time to collect as much data as you can possibly get. It's much more important to spend the time asking the right questions, collecting the right data, and then putting that to use. So energy spent on the front end as opposed to the back end, sifting through a whole bunch of meaningless information. So.
Based on your learnings in water and energy, do you see primarily monitoring applications, or in the future do you see monitoring plus control applications as being the driver of growth?
Yeah, we see, obviously, control is useful. The first thing that we've built that does control is the energy switch. Before that, everything we did was collecting data. What we have learned, though, is that, putting a lot of sensors out there and collecting a lot of data is the first step. That's where you get insight, and then insight can give you an idea about what's the best way to control this, or what's the most effective way. We like to stay away from control at a research level, because as long as you're not controlling something, the cybersecurity threat is less. The chance that you're going to, hurt somebody or wreck something is much less. So we like not controlling stuff. But with this energy switch, we're kind of getting into that, and so we're having to put a lot of engineering into the safety aspects of it.
And security.
Much more security than we had before.
So, and thinking beyond just visualization, this could be a few years away, but how far out do you see networks of things talking to things? Is that something that maybe it's already happening now, or is that something like a decade away?
I'm sure it's happening somewhere. It's something.
Yeah.
With that definition, I could imagine that it's happening somewhere. But how much
In your domain, I suppose.
Yeah, well, in our domain, I don't see it because because they are critical systems. There's always kind of like when they adjust to control the voltage on a network, they have to send a crew out and adjust a tap. They have to move a wire. They have to somebody has to push a button, and you should be glad of that, right? Because if our electric grid was automated right now with the way it's architected, it would be a disaster. It's very centralized, it's very vulnerable, and have that under automated control would not be a good thing. If you want to, the way we see automated control, in fact, we're writing a proposal right now with the DOE to do something that looks like that monitor, except it's going to sit on a utility transformer. It's going to measure the load of every home connected to that transformer, and it's going to measure the energy flow in the transformer and the temperature. It's going to also measure the phase angle, and it'll have a GPS timestamp on it, so you can actually do topology discovery of your grid. Something like that could be used to inform centralized control, the way they do today, but another benefit would be for low latency local control. So if that device, if that transformer controller can talk to the houses connected to it and tell the batteries to, or a request that the battery charges and discharges, it can actually nip problems in the bud before they spread to the rest of the network. And all that can happen independently at that location and not be subject to the vulnerabilities of a centralized control system. So that we're very much working towards a highly distributed control architecture that wouldn't be vulnerable to cascading failures and things like that.
Well, and that's the big promise with 5G, which is coming very quickly. So, systems talking to systems,
Right.
all distributed. Yeah. So how are you guys adjusting for the future of 5G? Does that factor into what you're doing? Will it be a cataclysmic shift, or will it be just a slow roll?
Well, again, we've got that cord sticking out of the box, so we'll just put a different, when people want to change radios, we're designing our system so that we can load a system with any radio anybody wants to use. And I think it really is about flexibility. There was a number of years where the whole smart grid, smart meter industry was held hostage by the standards groups. They said we're working on this Zigbee SEP 1.0 and 2.0, and this is going to make all these things possible. And it's an ugly mess. It doesn't work. And people were sitting around waiting to make changes to their infrastructure for this standard. So standards are important, but in a lot of cases we let the standards people get out in front and sort of bottleneck the progress, and we don't do that. We just if the standard is not there or ready, we use something else. We want to make systems that work and discover the value proposition.
It'll be interesting to see if those things can operate on parallel paths. I know there's a lot of conversation about new network rollouts in cities and smart cities, and municipality B will do it differently than municipality C. And so how do you manage the kind of efficiencies between those technologies in our cities, replicating all of that? Is it just a great mess? Should we look at kind of statewide or regional rollouts, or is it okay that it's messy in the beginning and everything will just kind of figure itself out at the end?
In my opinion, it's fine. I think what's important is that the community studies the problem and designs a solution in a way that's satisfying to them.
Nice.
And a lot of times that would be buying stuff that they make themselves in their own community. I mean, I don't want to see $80 million leave Austin and go to some meter company in Cleveland or whatever. I'd like to see that money spent here. We certainly can make our own water meters. We can certainly figure out what they need to do. So we should spend the next couple of years figuring that out and then making sure that money stays in our economy.
I was about ready to ask a question about that. So how does that work? Are they put out requests for proposals to everybody on the planet, or how? And people bid on the project, or
Yeah.
it sounds like a pretty big project.
Yeah, historically, it's my understanding, and I've never worked in city government. I've just observed a lot from recently. But my understanding is I've seen a lot of RFPs, and the RFPs tend to be huge dollar amounts and very complex. In fact, they're so complex that nobody can understand what they're buying. And what they should be doing, if you're going to spend $80 million, then you should spend $2 million on some pilot projects, and then maybe $5 million rolling out a couple of your preferred solutions. And then if that all looks good, you can start to scale those, or you might decide you need 2 or 3 different solutions for different parts of town because of the geography or the flooding potential or whatever. So that's the way.
That makes sense.
Yeah, that's the way that's kind of what we've done, and I'd like to see that more embedded in the municipal culture, how to do projects. Same with transportation. Why are we looking at $1.5 billion to build one system when we could be doing things all around the city, experimenting, and then going with the things that work?
I think really it's about fear, and municipal governments and staff, you get down a road and then all of a sudden you're judged whether you did it right or you did it wrong, and going backwards is so painful. But I completely agree with you that city administrators could be experts at being city administrators and leave the industries trying to solve challenges outside of just water and energy, not just they're the two largest.
Right.
But there are
Right.
groups that can operate in the same sort of way around transportation and affordability and construction and, all these kind of big city challenges that are not unique to Austin, but every city has their own flavor. So, I just wanna rally the world to help replicate this model so cities can focus on what they do well. You all can focus on what you do well, which is, the lab and the testing and the innovation and the commercialization, and then let the corporate partners come in, the university partners have their place. I think there's room enough for everybody, right?
Yeah.
All right, one more question, then we'll wrap up.
Do you have any projects on this water for leak detection and then control?
Yeah, leak detection is the main application for this, actually.
So what's the logic around detecting the leak, and then is it really just a report, or is it a control where it can actually shut it off?
Well, this device doesn't control it. We actually worked, when we first started this, before we started making our own water meters, we were very hopeful. We found a company, a Texas company, that made a water meter that had a remote control shutoff valve built into it, and it recharged itself with the flow of water going through this meter, instead of recharge the battery. Well, it turns out it didn't recharge itself. And particularly if people weren't using a lot of water. If somebody went away on vacation, it wouldn't charge itself. And even when they did, there were times where it just couldn't keep up because there was so much data coming back. And so, and then they did win a couple of contracts. I know at least one municipality, before they were allowed to deploy, they had to disable the shut-off control because the city had a law. I think this applies to Austin. There's a law that the water company cannot deploy a remote shut-off technology. For whatever reason.
Even if there's a leak and there's thousands of gallons running into the ground or down the street.
Yeah, I mean, I guess you could do that on your side of the meter as a private citizen or as a commercial business. You could do that. But
It just seems like the logic would be easy, right? I mean, you've got a sophisticated computer there that knows the pattern.
Right.
Once it detects a pattern that doesn't fit my normal,
Yeah.
right?
Oh, we could
Toilet
definitely see
leaking,
leaks.
hose left undone, right? It just goes click, it turns it off, right? I get a red light in the yard, I gotta understand the problem. I mean, how easy is that?
Yeah.
That's the challenge with policies that are put in place that are here for decades and decades, that were maybe applicable when they started, and then fast forward, it's very, very hard to undo policy, which is why we always advocate for policies that can be a little bit more flexible, especially in smart cities and, with this kind of technology. Who knows what the world will look like in 10 years, so we need to make sure the regulatory and policy bodies can adjust with it.
What happens to the patents and all this stuff?
We kind of like to stay away from patenting things, mainly because we have commercial sponsors, and we don't want to interfere with their ability to exploit this. We have a lot of protection when you build one of these systems, it's really hard for somebody to rip it off, because if you didn't write the code, if you didn't deploy it, you don't even know why it is the way it is. So we would rather compete by just being out in front of everybody than sitting back on an IP portfolio. And I've been in this business too long, and I've wasted too much money on patents to even think that way. So we just don't do it.
Are you working with the city now? Are you getting money for the water project? Are you consulting with them, or, okay, so you're not even.
No, we consult with Austin Water free of charge. We have them over for informal meetings and just show them what we're working on. If we wanted to consult with them, we wouldn't be able to talk to them.
I see. So you're not gonna bid on anything?
Right.
You're not gonna bid on anything?
We're gonna stay out of Austin politics, because all that is very political. So we're just trying to inform, we have a grant with Austin Energy. They got the DOE Shines grant for like $4 million to put storage, and they've subcontracted us to do the residential energy storage portion of that. But that's very specialized work. But yeah, that's a good question. There's a lot we could get into, but I think we'd rather help them make the right decision than actually go after this.
So one last question, then we'll wrap up.
Very general question. Are you seeing an acceleration in the time find that you have to sort of take a pilot and get it, and what made me think of that is the thing you're talking about where it can control houses, and I was thinking you might have to bring a security company into your grant writing process, just because as 5G and things, the enablers sort of ramp up, the expectation is a lot of these projects become commercialized faster. Are you seeing kind of the appetite for things to go from proof of concept to, you know, to like beta to production to commercial faster, or is it still?
Yeah, it does where we work, and the reason is because what we try to do is figure out why something is not going to be a good business as fast as possible. We almost had a couple of false starts early, like after we'd been around a couple of years. We were like, okay, let's go raise money and go commercialize this app. We had an app that showed people where all their residential energy, how it was being used and everything. And there were like 5 or 6 other companies out there raising money for the same thing. Some of them got a lot of money. But just as we were getting into that whole, caught up in that, we realized that people didn't really want that product because we just kept pushing it. We didn't just assume, okay, people are gonna want this. We really tested it, and we've been doing that all along. There's a lot of things you hear that people might want this or they want that. The key is go find out and put it in their hands and simulate the product any way you can, as quickly and as fast as you can, and prove that it's not a business. And if you keep doing it and you can't prove that it's not a business, then you're onto something. And that's kind of where we're getting at with a couple of these products. Yeah.
Nice.
So if you have one call to action for everyone in this room and folks who are watching online, what would you want people to do? Sorry, I stumped you on that one.
Well, I mean, if you're interested in IoT
Yeah.
or data analytics or any of that stuff, then pick a domain and become a domain expert. Don't get wrapped around the axle on being great at the IoT part, because that's gonna be like a common skill, right? That's gonna be like spreadsheets and word processing where, years ago.
Yeah.
So everybody's gotta be an
Everything,
IoT
we'll talk to
expert.
everything.
Yeah, so that's what you have to be good at, is what's your domain and what do you do with that data?
And hopefully how do you use that expertise and talent to solve problems that the world really needs us to solve.
Yeah.
Thank you.
Thank
Thanks
you.
so much for